This Delta Math topic is use structure 1, 0, and infinite solutions level 2. Ooh, level 2. Here we go. All right, quick recap. When you are simplifying an equation down, you get to this point where you see what's about to happen, okay? So let's say I had an equation where I had 7x plus 4, and I don't know why, but I tend to always use 7x plus 4 as this example. If I had 7x plus 4 on the left and 7x plus 4 on the right, well, look, my amounts of x's are the same and my constants are the same, which means it does not matter what number I put in there. If I multiply it by 7 and add 4, and I multiply it by 7 and add 4, I'm going to get the exact same result. I don't care what number I plug in there. I can plug in any number that ever existed, infinitely many numbers, okay? And that's going to be a true statement. It's going to, the left side will equal the right side. But what if I took 7x plus 4 and then did 7x plus 3, not 4? So I take a number and multiply it by 7, and here I add 4, but on the right, I add 3, and I'm expecting them to still be equal. How crazy am I? Okay, very crazy. And there is no solution, okay? No solution, 0 solutions. Okay, same thing, no or 0. Finally, I could also do 7x plus 4 equals, let's say 6x minus 5. Honestly, this part doesn't matter. If you see that you have different amounts of x's, you're going to be able to get, like, if you move, once you round up your variables on one side, you're going to have 1x right over here, or it could be 2x or 5x depending on the equation, but you're going to get one set of x's, and you will be able to solve for that, and you're going to get one nice neat solution. Okay, infinitely many solutions is like a mirror image. Okay, no solutions are when you start to look like a mirror, but then it's like looking in the mirror, you're holding an apple in real life, but your reflection is holding an orange. Not happening. And then one solution is when you just have different amounts of x's. So you on this topic, you have to look at what is my goal. And this one says this equation will have one solution when h equals blank, because you get one solution when you have blank, blah, 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 blah. Okay. It's hard to do because I don't have all the answer options, but I think it's like saying like, oh, different or same amounts of this or that. Okay. Okay. So if my goal is to get to one solution, this is what I'm looking for. I want to get different amounts of x's. So it says this equation will have one solution when h equals what? Okay. So here's my h, because you get one solution when you have the different numbers of x's on either side of the equation. And then it says something here like, it doesn't matter if your constants are the same or different, okay? Because it doesn't matter, because our focus is on the x's when we're talking about one solution possibilities, okay? There's actually like a ton of different possibilities, a ton of different possibilities, because all it has to be is just different than when we simplify over here. Okay, and I did this actually, I was having a student with this earlier today, ironically, and it just says this will happen for any value of h except when h equals 8. So you're like, oh gosh, what's that one perfect answer? Well, no, it's like literally every number in the world that ever existed except for the one that couldn't make it true. So they went enough to simplify it out. They distributed their -8 to get -8x plus 64. And so they're saying, look, this just cannot, we cannot have the same amount of x's. This cannot be -8 x's when all is said and done. So h cannot be 8, because if h was 8, that would be negative. That would be 8 times -1. There's like a sneaky little hidden -1 right there. Okay. So 8 times -1 is -8. So that's the only one that it can't be. Okay. So that one is, that's just stretching your thinking a little bit. But don't be too scared of it, okay? So if you are not sure about what I just wrote down, either write down the notes that I did with the 7 x's and the amounts of solutions, or maybe you can like remind yourself with this. This is right on Delta Math, and they're gonna give you your little tips for what is allowed to be same or different, okay? The next one's a little bit easier because it's not one solution. This one is 0 solutions, and when it's 0 solutions, remember your x's match up, but then you do something different. Okay, so we want to find a way for our x's to match up, and then assuming that when we do that, we're going to get a different number than -32 over here. So what times 2 is going to give me 8? Well, that would be 4, because 4 times 2x is 8x, okay? So that would be 8x. And then we have to still distribute 4 times 10 is 40. So when we compare those two things, we're saying, all right, same amount of x's, but look, you're doing two different things and expecting the same result. After we multiply by that number by 8, and we add 10 or we subtract 32 and expect it to still be the same and equal on both sides. Nope, not that lucky. Okay, so h would have to be 4. So that's the only answer here. H would have to be 4 because you get 0 solutions when you have the same number of x's, but different amounts of constants. Okay, different amounts of constants is why. So be very familiar with what gives you infinite many solutions, what gives you no solutions or 0 solutions, and then what gives you 1 solution. And you're gonna have to, it's like figuring out the puzzle and doing that. Okay, again, more explanation from them. They give you the little chart again to remind you. Take your time. Don't be afraid to persevere, even when you feel like you're not getting it right. And email me if you have any questions. Ta-ta.